Hi everyone, I'm Marvin, and this is part 2 of TCC's Cloud Load Balancing Architectures. Just bear with me, I'll just get this opened up. Okay, so at the end of part 1, we talked about how a physical ADC appliance was better suited for a network edge, or should I say an internet network edge. So I'm not going to go back into all that. If you want to see all we talked about, please check out part 1. Right, so let's move on to part 2. So we have this diagram over here. Now let's pay close attention to it. It shows 2 on-prem data centers connected to the internet. So you have data center 1 over here, and you've got data center 2 over here. Okay. Now future examples will use a similar model, but where relevant, they will also show any other off-prem locations, maybe in the cloud or other data centers. Okay. Now the internet routers here are deployed as an isolated pair. So 2 isolated pairs. You've got an isolated pair in data center 1 and an isolated pair in data center 2. Okay. Now this allows for separate layer 2 failure domains, which is opposed to having stretched VLANs between both data centers. Okay, so basically effectively merging the data centers into a single failure domain. Okay, all those who know spanning tree will know exactly what I'm talking about. Now, I know there are those who might still swear by stretched VLAN designs, and sure, it's still in deployment today. But with the move towards the abstraction of layer 2 and layer 3 in this day and age, VLANs can be stretched across multiple locations with all the benefits of layer 3 routing and none of the drawbacks of layer 2. Of course, there are other elements to consider here, such as the switching and internet routing design. However, these will not be discussed here, as we are trying to show the implications of load balancing. So if we peek behind the routers, there are 2 separate pairs of stateful firewalls here. So a pair in data center 1, a pair in data center 2. These firewalls are leading to an inner zone. I like to call this your landing zone, something like that. And this is where ADC devices are located. Okay, we've gone for multiple brands here. As you can see, we've got F5, Citrix, Riverbed. Well, in theory, all this is just a pair. You pick whichever brand you want. So you can have a pair of Riverbeds here, a pair of Citrix, or a pair of F5 on both sides. Okay. Now, the diagram also introduces another key device not yet mentioned, global load balancers, as you can see here. Okay, so in this scenario, we have global load balancer in data center 1. Again, we've gone for multiple brands, it could be any. Another global load balancer in data center 2. And a third, which is acting as a VM in data center 3, which in this scenario is the cloud. Okay, obviously you can have a third data center physically, but obviously because this is a cloud session and we're trying to, promote usage of the cloud, we've put one in the cloud. And different companies can do what they want. Some companies decide to do that. Some companies just decide to use a third site. It doesn't have to be a major data center. It's almost acting as a global load balancer of last resort. Just in case your primary data centers are dead and you still want a global load balancer to maybe send you somewhere to get a sorry page, or maybe the site it's resided in can serve the sorry page. Or you can leave it all in the cloud. There's so many options here. I guess that's what we're trying to get at. Okay, so talking about global load balancers. if we quickly sort of try and understand what it is they do, yeah. In a nutshell, global load balancers distribute traffic to multiple sites by manipulating DNS responses. It can do this using numerous methods, such as round robin, for example. But let's look at a particular scenario. Let's assume a user. A user we'll call user 1. User 1 sends a DNS request for the IP address of an FQDN. In this instance, the global load balancer will return the IP address configured on the ADCs in site 1. So this is the VIP, if you want. I'll call it a VIP. The VIP configured and the pair of load balancers here is what's returned. Okay, so that's what's returned to user 1. And then we have user 2. User 2 does exactly the same thing. He sends a DNS request for an FQDN, the same FQDN. Except this time, the global load balancer will return site 2's ADC VIP address. And on we go, with each new user getting sent to both data centers in a round robin fashion, or thereabouts. And at its simplest form, that is global load balancing. But as we all know, nothing is that simple. There are also lots of nuances to consider, such as the fact that deep proxy devices actually make the DNS requests over the internet and not the actual users. Then there's the matter of how global load balancing works when the actual GLB device sits behind a company's DNS server rather than in front, because you could go either way. Then you have discussions around DNS time to lives, persistence, and all sorts of stuff. I really do wish I could talk about all of that here, but like cloud computing, that alone could take an entire presentation. Now, I plan to cover many of the topics highlighted earlier in this volume, but if there's anything you would like to see that was not listed here, please don't hesitate to request it on our website. And our website is www.tcc-plc.co.uk, or if you do manage to get this whole presentation deck, my email details are right at the end. You can send me a personal email and I'll be more than happy to provide as much information as you need. Now, getting back to the global load balancers, one thing of note is that they're sitting right beside the internet routers rather than behind the stateful firewalls. And no, that isn't the mistake. In fact, it's a much more common design principle these days. If we go back to what we were talking about earlier regarding DDoS, I think we've established that it's pretty serious. Let's briefly put aside the fact that it can cause significant service disruptions and huge losses. It can also mean significant reputational damage, something that can take even longer for companies to shake. Now, there are many forms of DDoS, including one that attacks DNS. Yep, that's right. DDoS can also attack a company's name service. But is that bad? Oh yes, it's pretty bad. Without name resolution, traffic will not find its way to your front door, and the attacker would have succeeded in his or her goal of denial of service. So why does placing the GLB above a stateful firewall help? Well, firewalls, like every other stateful device, has limits. Whether it's concurrent connections, embryonic connections, maximum connections, etc., the fact is that they can have as much throughput capacity as they'd like, but once a connection limit is reached, traffic drops will start to occur. All an attacker needs to do is exhaust these limits, and the firewall will not forward traffic to the GLB, thereby rendering the name service inaccessible and triggering a DDoS without even having to exhaust the protected device, which in this case is the GLB. So by leaving the GLB in front of the firewall, as shown in this diagram, an attacker cannot cripple DNS by attacking a stateful firewall. It's also worth noting that the GLB appliances being proposed here are hardened security appliances with built-in protection for the DNS service it provides, and that is true across each of these vendors we've mentioned here. Now, as with the network design in general, this is just a design option, and it's perfectly normal to deploy GLB devices behind firewalls, so we could just as easily have placed them here. In fact, many organizations do this. Some also place extra protection on these firewalls to protect from state saturation attacks. Hell, many are now even placing them completely in the cloud. So we've talked about having a GLB device in one data center, another in another data center, and one in the cloud. This is just one design option. Another design option is to have your GLBs completely off premises. It is absolutely acceptable. There's no right or wrong answer. I promise you that. And as always, TCC consultants are on hand to answer any questions you might have regarding this topic. So if we move behind these firewalls now, we see our ADCs. Again, they're all deployed as individual clustered in both data centers with no stretched VLANs or cross-campus connectivity. So features like SSL offload, caching, web application firewall, a pretty big one, and much more can be done here. From here, traffic starts moving towards the inner tier, which is where VADCs start to come into play. Okay, so with that said, that's it for part 2. Now, if you'd like to get all the parts that make up this volume for a one-off price of £19.99, please go to our website at www.tcc-plc.co.uk. But for now, I'd like to bid you farewell, and hopefully I'll see you in one of our other parts.